So if I sound like a Google salesman, just let me know, because it's not my intention. But I think
you're just excited about it. That's cool.
well, I think the technology is interesting.
I remember when we used to have to move stuff around on floppy disks. Now software has come so far.
Yeah, well, those are the good old days when virus cannot really spread too fast.
No, they couldn't.
It can only spread as fast as it can walk to the next workstation with a floppy disk. I mean, you can infect the entire corporate structure, using a floppy disk, but it would take a few days.
You'd have to be the agent to carry it around.
There's a lot of legwork involved. Yes. These days, within seconds.
Really does make you kind of wonder how brittle the whole thing really is.
Exactly, because it was not very strong before, but it's flexible. In other words, you can hit it on one part, and then the other parts go like, what happened?
You can take a nuclear bomb out, and the traffic would reroute itself.
It's self-annealing in a way, okay, or self-limiting in terms of how fast damage can propagate. And then these days, once you figure out a way in, and it's part of the real infrastructure, it would just go like, it's like tempered glass. You just crack one spot and go. And we are continuing to head that way too. So that's it's interesting. The next 20 years, I think, in terms of cybersecurity, we'll see some really interesting stuff going on.
Well, we got quantum computing coming. Everything's undone.
Even before that's going to happen, I think we'll see computer security becoming a major topic every single day.
Oh, absolutely.
Yeah, forget about nuclear weapons from North Korea, because with cybersecurity and hacking and all kinds of stuff like that, you don't need to have the centrifuge to do any type of weaponry. You don't need raw material.
Wasn't it the neutron bomb, the one that killed people but left the infrastructure standing?
Supposedly.
Yeah. Now it's just cyber terrorism.
Oh, because it's far more effective. There's no need to launch anything.
What's really going to be effective is those people that know how to write a note and leave it on the trash can, and you walk by and pick up the note on the side of the trash can. I mean, we don't have any defenses against any of that stuff anymore. That's foot soldiers.
Yep.
They can pass messages from here to there without ever
getting traced, and we have lost the
ability to trace them,
or even the idea that things can be spread that way. Information can be passed along without electronic means. Cool. All right. Well, I guess we'll get started because it is 9 something. Okay, somebody cranked the volume all the way up. I like it. It's just a little bit more than my normal voice, but not too much.
Is the recorder on?
The recorder should be on. Yep, it is on right now. And there are actually a few things I need to check. I need to make sure it's actually streaming the audio as well, so it's recording the frames, so that's good. Because one day I used the wrong extension, MP3 instead of MP4, so it recorded only the audio portion.
Oh.
Yeah, the encoder is really smart. It looks at the extension and go like, oh, you mean you just want to encode the audio portion? Sure, no problem.
Not good for your viewers.
No. No, well, related to that, okay, I want to show you this, just because, I found this Berkeley Video Library accessibility. Oh, that should be enough. There we go. There we go. So this is something that is interesting in a way, but I find it a little bit disturbing as well. Berkeley, okay, so 2 students from Washington, D.C. Decided to use, to watch some of the videos that UC Berkeley had prepared and made public to the entire internet. Okay, it was not closed and closed captioned, unfortunately. So the two students, proceeded to talk to other people, and it ended up, having the U.S. Justice Department to order UC Berkeley to either close caption all 20,000 videos that they have put online, or take them off.
Holy smokes.
Okay, it was two students from D.C., Washington, not even as Berkeley students, who decided, hey, this is not good. We are deaf, and these videos do not have closed captioning. Let's go get Berkeley to do something about it. So the DOJ decided to give Berkeley an ultimatum to either take down all 20,000 videos online, or close caption all 20,000. Now, I'm not sure how many of you have tried to close caption your own video, let's say a 5-minute thing. It takes a lot of time, okay? A 5-minute video, even with a professional, takes more than 5 minutes to close caption. If you're a novice about this, 5 minutes would take you half an hour, easy. Okay, just to figure out what to do, because you have to, you don't have the necessary equipment, because the transcribers usually have a foot control to pause and unpause the video. But if you don't have that, then you have to move the mouse around, and guess what? When you move the mouse around and click on something, the window changes focus too. So to close caption 20,000 videos would have costed Berkeley a huge amount of money, depending on how long each video is.
It seems like the judge would have said, from this point forward, you should have to do it instead of going back.
Or if you want to accommodate those students who are not even Berkeley students or California residents, who you can say, okay, tell me what videos you need to watch. Okay, we'll definitely put in closed captioning for those that you're going to watch, and then from here on, of all the new videos, we'll put closed captioning on it. But to go back and say, let's go close caption every single one that you have online, I think that is a little bit unreasonable. People who need accessibility would probably disagree, because it is, once again, this is about equality versus equity. Not sure whether you guys have seen pictures of those two concepts, kind of depicted using a picture. So we have equality versus equity, and they are not the same thing. Let me see if I can find an image of that. There we go. This is a very typical picture that shows what is equality. With equality, they're all standing on the same blocks. With equity, they are all watching the show. So that's the difference between the concept of equality as opposed to equity. One is how we treat people. The other one is based on how they can accomplish. So I'm not going to say which one is better or which one is the right one, okay? But in life there's no equity, unfortunately. That's just the way it is, okay? We were all born with different pathways in our brain. There are certain things that are innate to us. We are all good at different things. So true equity is just not possible. But equality, I think, is possible. We just treat everybody the same way. Can be the same good way, can be the same crappy way, it just has to be consistent. If I'm mean to people, I just have to be mean to every single one without exception.
That's what I do.
Exactly, that's equality right there, okay? So, I think, it's changing. Yep.
You don't think there's a software solution to that?
I do not know where they house the video. I don't know whether it's YouTube or Berkeley has their own multimedia server, which is serving out these videos. If it's YouTube, YouTube does have automated transcription.
They do?
I think some of mine, has automated transcription. It may not be very precise though. I mean, it's not as good as
Nobody said it had to be accurate. It just has to be a transcription.
Mm-hmm.
You know? Unfortunately.
It seems like, there's an automated method or what do they call it? Where you have everybody participate.
You have a lot of
You know how they did with
Oh, Charles Bronson McQueen.
Oh.
Okay, so
They're pilots.
Okay.
It's a true story.
Oh no, that was actually
But this is a
appropriate.
parody of that.
Okay.
Yeah, and it was British. It was a British camp in World War II.
Oh, I've seen that.
Yeah. Yeah.
That was scary.
That would work for all.
Yeah, it worked okay.
It seems like that would be sufficient for their needs.
What it does is it has different colors, and if it's a lighter color, it means it's not sure about that transcription, and if it's a more bold white, it means it's pretty sure about that one.
Ah,
Oh, good. It's confidence in there.
yep, his confidence level. Ooh, cool. But anyway, I just want to show you this because that can potentially impact how I do my recording and how I distribute my recording. Worst come to worst, I just have to not make it public, okay? And then I'll send you guys a post the link in Moodle, and then just make it unlisted.
Yeah. That's
Yep.
what my other professor, she works at the web side, but she doesn't make it public.
Yeah, Carol
She's a-
Lever, right?
Yeah.
Yeah.
Right.
Yeah, well, she is, a little bit more shy, I just decided, hey, anyone who can potentially benefit from my video, just go ahead and watch it. If you say, okay, this is not what I want, fine, it's not a problem. But, making it public, means that, anyone who want to watch it can watch it. Okay, just in case there's somebody from a different state and they want to learn how to do mobile programming, just for whatever reason stumble into my videos, they can learn everything that we learn in class. I don't have a problem with that. So, and that's the reason why I made it public is, since it's already done, might as well, just make it public.
Yeah, and it's good to have a public, but I mean, I think that, I can't imagine there's not a master's program right now at Berkeley to solve that problem. It's like someone, professor probably stood in class and said, we need someone that can automate transcription
Yep.
to some degree.
Well, YouTube can automatically do it. Every single video that I make, with this class, is already transcribed.
Yeah. So maybe they could privately publish it to YouTube, give the transcription, and move it back to their system.
Yeah, something like that. They can certainly do it that way. But Berkeley, I think Berkeley as an institution is just kind of upset that for doing something to try to benefit everybody or the majority, they got slapped for this particular reason. Okay, so I didn't have time to really push my notes into Moodle, so I will do that later. For those of you who want to kind of follow along with the notes, which I don't think is going to be necessary, you can go to this particular URL. It's moodle.losreals.edu, and then the TUEUNG symbol, TAUYEUNG/teaches, TEACHES, modules, and then the module number is 0274. I can just pause here, let you guys take a picture of that or whatever. It will be linked into Moodle later on. It's just that I did not have time to do it this morning. And all the modules that I have ever written, can be found in the subfolder of modules. They just have a different number, that's it. Okay. Alrighty. Okay, so we'll go ahead and move into Firebase. So today's lecture is going to be interesting in some ways because it's not just me talking about reading my own notes here. Instead, it's going to be a demonstration of how to set up Firebase and also an explanation of what it is. So Firebase is many things. It's not just a backend. It's not just a database backend. It's multiple things. So if you want to follow along, you can go ahead. I'm going to use a private window, incognito, in order not to have the cookies of this window to interfere with the other one, because otherwise they would interfere. So I would go to firebase.google.com. So Firebase is actually a product of Google itself. It is not a third-party product that Google is working with. So once you get to firebase.google.com, it will ask you to sign in. You can sign in using any Google identity. Okay, so if you have your own Gmail, you can use that. You can even use the one from the school. So if you want to use the w blah 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 at apps.losreals.edu, you can sign in with that one too. In fact, I'm going to show you how that is done. So I'm going to sign in, and I'm going to use my w at apps.reals.edu account, and it will defer to the Lost Reals website to do the actual authentication, because this is based on the Active Directory at the district. But after we sign in, we'll go back to here, and it doesn't like it. Okay. So I probably have to sign in using another, oh no, there we go. Okay. So it just, I just signed in as my Lost Reals employee account, and then we can get started for free. So when you click Get Started for Free, it will bring you to the console. This is known as the console of Firebase. Firebase. You can tell this from the URL because it says right there, console.firebase.google.com. So with this, there are several things you can do right now. You can go through the documentation and find out what it is, or you can just kind of dive right into it and create a new project. Okay, which is usually what I do. Okay, just click the button. Create new project, and we'll just name our project something here. We'll just call this test db2, test database 2, and then click project. Click create project, and it doesn't like it because I think it still doesn't work with the Lost Reals account on it. Okay, so I'm going to sign in using another account. The Lost Reals account probably has a problem because they specify what services are available and what services are not available, and Firebase is not available, unfortunately. But the warning message or the error message doesn't say specifically why it is failing. It just says, oh, we failed. Okay, so I'm going to use, I don't want to use the one for this semester because it's already set up, because I want to kind of guide you through the whole process to do it. So I'm going to use some really early ones like 2016 spring. There we go. Okay, done. All right, so we're now back here and double checking my account. It is, no, switch. Okay. So let me double check, make sure it is switched. Okay, it is switched now. So we'll go ahead and go to Get Started for Free. Getting back to the same page, and this one already has a project in it. That's okay. We can always still click create new project. So the first thing we'll notice is it says project, not database. Okay, let me get back again. Create new project. It didn't say create new database, because Firebase, despite what the name implies, is not just a database. Okay, so every time you create a project in Firebase, you're creating a container of sorts. Okay, but within the container, you have several components, and they can interact with each other. So once we create a project, we'll see what kind of components we're dealing with here. Okay, so we'll go ahead and call this test 2. Okay. It doesn't take long to create it. It is free because I have not registered any payment arrangement with this Google account yet, so it cannot possibly charge me money. Okay, there we go. So from the left-hand side, you can see what it can do or what you can develop. The first one is authentication. If you remember from last Wednesday, Firebase can use various providers for authentication. And the ones that we know for sure that it is currently supporting would include Gmail, Facebook, and GitHub. So if you have an account with any one of these 3 providers, instead of setting up a new account for your project every single time, you can just have your end users to reuse their identities in Facebook, in Gmail, or GitHub. Okay, which I think is a big thing, because how many people have already thought that, okay, I got too many accounts to manage already. Okay, I will use both hands, okay? Because every single financial institution want you to sign up with your own account. So you have to find a username first, okay? And if you're Michael Smith, I'm sorry. M Smith is already used. M1 Smith is used. M2 Smith is used. Smith M is already used. Michael Smith is already used. Michael Dot Smith is already used. Okay? So it just doesn't make sense at all. Okay? That you have to create a new username. And then it will come back and ask you, what is your email address? Well, the email address is unique. So why not use the email address as your quote-unquote username? And then it will ask you for your password, okay? And then each institution has a slightly different rule to specify what is a minimum or what is acceptable as a password. I can think of the most convoluted password using all the @ symbols, parentheses, digits, uppercase, lowercase, and make it 30 characters long, okay? But some institutions will not take it because they do not accept the use of parentheses, but everything else is okay. So you can't even use the same scheme for every single site that you want to set up an account with. Okay, and then 2 months later, you come back and go like, okay, I want to check my investment. Well, good luck remembering what username you have and what password you used. So, as far as I'm concerned, this is a really cool feature to be able to use my Google identity to link to my whatever account I need authentication with. Is a great thing. Okay. Now there's a problem with computer security in this case, because if for whatever reason, if Google authentication is hacked, okay, then whatever data is available there can potentially impact all of my other accounts using Google sign in. Okay, so there's that potential problem there. But otherwise, to the end users, okay, not counting the potential of computer security issues, this is great. Okay, have everything consolidate to just 2 or 3 accounts, so you don't have to remember all the different passwords for different things. Okay, so that's the authentication piece, which is what we'll be focusing on today. Okay, I'm just hoping that we can get through the authentication piece today. The second piece is the database. Okay. Once again, it is called a database, but it is not what you think of database. Okay, when we think of database, we think of Oracle, we think of MySQL, we think of PostgreSQL, we think about SQL. Okay, we think about relational database. You can join tables, do kinds of search and whatnot. This database is entirely different. Okay, how many people remember that we talked about JSON in cisp363? Okay, we talked about the key value pair list, right? That's what it is. So it's a hierarchical key value pair list, okay, which has different names in different programming languages. In Perl, it's called a hash. In PHP, it's called an associative array. In Python, it has a different name. I put in my notes, but I forgot that name already. But basically, it's just a way to you give the system a key and they retrieve the value for you. Okay, but what the value can be a string, can be a number, can be another long, big, huge list of key value pairs. Okay, so it's hierarchical in nature, and that's what the database is. Okay, it has no tables, has no columns. Okay, everything is just quote unquote associative, but it is hierarchical. Okay, and so hierarchical only up to 32 levels, and then when you read the documentation, it tells you do not make it too deep, because if you make it too deep, it makes efficiency an issue, because every time you retrieve a node, it retrieves all the children as well. And then it also has an impact in terms of security, because when you set up permissions, the parent's permission cannot be overridden by the child. Okay, it is if your parent specifies a particular permission, the child cannot override it. So if you make it too deep, it makes managing security an issue as well. So that's an interesting backend. Storage is no more than just putting stuff into the cloud and be able to retrieve that. It can also do hosting, so you can, without making your own virtual machine, you can host a website using Firebase. Now, I haven't really explored that part, okay, but I'm suspecting it is also fairly easy to do. You can set up functions, and these functions are kind of floating functions sitting in the cloud somewhere. So you can associate functions with your database, for instance. Okay, every time a particular thing changes, these functions can be triggered to execute. In other words, your database backend itself can be intelligent. It is event-driven. You can specify not PHP. You can specify JavaScript code associated with all of those triggers. Okay. So what we'll do today is to focus on authentication, and also, if we can get into database, we'll get into database a little bit. The database part is interesting in some other ways too. Instead of using the traditional database concept of you are granting specific permissions to a particular table based on the kind of end user, this one is set up entirely differently. It allows you to specify rules, and the rules follow the same hierarchical structure as your database itself. And then within those rules, you can specify not PHP, once again, it's JavaScript code in order to specify who is allowed access into which node of the key value pair hierarchy. It's interesting. It's very interesting. Okay, so we'll first go to the authentication piece first. So I'm going to click on authentication, and with the authentication piece, you have to. It's a way to maintain the identities of the end user of this particular project. We doing okay so far? So authentication is not about you, the developer, authenticating against your project itself, because that's just signing in through the website, easy peasy. Okay, this authentication is about your end user, people who install your app, authenticating against the back end, so that it is easier for your apps to maintain its own list of end users. Are we doing okay so far with that concept? Okay. So with this, you can now set up. You can add users specifically, but you can basically also use set up sign up methods. And by default, everything is turned off. So everything is by default turned off. You have to enable these particular features if you want a particular one. The first one is having your database to maintain its own association of email versus password. So we can do it, but that means your end user will probably either reuse the same password as their whatever email address they choose to use, or they have to come up with a different password. So we're getting back to the old issue of I'm maintaining way too many accounts. Okay, but this alleviates that problem a little bit because it is using the email address instead of a chosen end username. Okay, but the second one is more interesting. The second one, the third one, these four are more interesting because it's using a provider for authentication. So if you want to enable Google sign in, which means instead of having the end user to come up with a email address, okay, I'm going to use my Yahoo address, I'm going to use my Comcast address, and then with this password as my account to be used with your app. Instead of doing that, now you can use Google sign in, which means the end user can just say, oh, okay, since I'm using an Android phone, I already have a default Gmail address associated with it, and I just want to use it as my identity for this particular app. That makes it very automatic, very easy to do. So we'll go ahead and try to enable this one. So you click it. So the moment you click it, it pops up this particular window, and you can obviously slide the enable part. Okay, that's the easy part. Like that. Okay, but the other part is, in order to use Google Sign In, you need to upload the SHA-1 fingerprint of your app so that your app is registered with Firebase. Okay, so why do we need that? what happens when that requirement is not there? In other words, what if Firebase says, I will talk to anyone who asks me about user, a list of registered users.
You can see anybody else's data.
Potentially, yep. So with the SH1 fingerprint, now this database or this project is linked only to the apps that you have for which you have uploaded your SHA1 fingerprints. It is not limited to just one. Okay, let's say you have 10 apps and 10 different developers, and you guys say that we want to share the same user base. Okay, that's okay. Have all those 10 apps from 10 different developers upload their SHA1 fingerprints, and they can all use the same Firebase project.
So you're saying one project can have multiple fingerprints that are allowed?
Yes.
Okay.
Question?
That's sweet.
Yep. So it's really kind of cool because now you can have a co-op of developers, and so I can think of many scenarios for tutoring, for instance. Okay, so you can basically have an organization, kind of loose organization of tutors, and individual tutors can develop something that's specialized to the subjects that they are teaching or they're tutoring. So the calculus person can do a calculus tutoring app. The English writing tutor can write an English writing app to help their students to do something. But they might want to share the same Firebase backend because all of those students are still kind of related, and they may want to share the data. So in that case, you can upload the fingerprints from these different developers, and they can now share the same Firebase backend. Yep.
What if you have a number of developers working on the same project? Do they use the same fingerprint, or do they still use?
They can choose whether to use the same fingerprint or not. If they are all working on the same app, Android app in this case, then they by default already have the same fingerprint.
Okay.
On the other hand, if they're working on different apps, okay, then they can potentially have different fingerprints.
So what if you have someone working on the website, someone working on the app side, but they all want access to the same data, they use the same fingerprint?
The website has a different idea of what we have worked on right now is specific to Android apps. But if you're using a web app, it has its own SHA1 fingerprint as well.
Okay.
So from the backend perspective, from Firebase's backend perspective, it doesn't even know what the fingerprint is for. Okay, it can be coming from your Android app, can be coming from your web server that you're maintaining yourself. It can be a Google hosted web server that you're using, but whatever that entity is under your management. And this established the trust relationship between Google API or Firebase and whatever is under your management.
Okay.
So basically, if you have this fingerprint uploaded and you initiate a communication, the communication protocol itself would upload your certificate to Firebase in this case. The Firebase can double check and go like, okay, are you who you claim you are? Okay, and then it will cross-check your certificate with a list of fingerprints that has also been uploaded. If it is a match, then it will go like, yes, you may talk to me now. Okay, if it does not match, then it will just say, I'm not even going to talk to you. There's no, it will stop any further communication after that. Is that okay? So that's the first level of computer security, is to make sure that whatever is talking to Firebase is already registered. And it will only talk to some entity that is already registered and go like, yes, this thing may contact you. Is that okay? So what that means is we need a way to get to the fingerprint, and if you click it, it will give you another page that shows you the command line to do it. Okay. Last time I think we did something like that already. Okay, we set up a key store. So what you need to do is to find out where your key store file is, and then run this command to get the fingerprint out of your key store. Is that okay? And I think we have just that. Okay, so we'll go ahead and figure out that. I may have forgotten entirely, what keys, what are the names of the keys that I have previously used. So we'll start up. Let's see. Yep, I do have the keys here. So this is a key store file, and I just need to see if I can remember what keys I have set up last time. And where's my? There we go. Okay, so we got the commands, and then we got the command prompt. Just need to scroll it in a way that I can look at both at the same time. Maximize this. Move this one slightly under. There we go. So key tool export cert -list -v -alias. And I cannot remember my actual key name. I'm going to try test 0 key store, and that's just going to be Android keys.jks. Oh, it is the right one. Okay, let's check the password. Oh, okay, I got lucky this time. So the SHA1 signature is this number here. So what you do is just copy it and then go back into here. And let me see, where did I put? Oh, yeah, right, because I have to use a incognito one. So there we go. And it also tells you that you have to do it in the project settings in the Firebase project. There we go. Okay, so we click save to save the enabled status. There we go. Okay, so now we need to go set up our security, which is done by clicking on the gearbox first, and then go to project settings. And then within project settings, you can see that there's already one web API key, and this is the web API key from the perspective of Firebase. And then we go to Android here. Okay, so now we have to give it a package name, which I don't have yet already. Okay, which I don't have yet, but you can see that the bug. This is optional, but we can also add another SHA1 key to it. But I think we need to set up a package name first.
The package name matches the Android project.
Correct. Yep. Okay, so we can bring up one of the older projects that we already have and just use that as an example. Okay, so we'll unmaximize it. Android Studio bin Studio. I know there's an update. I'm not gonna do the update just yet because that's gonna. I think it's gonna be a major update as well. It just came out this morning because I didn't get it last night. There we go. It's a platform update. Anytime you have a platform instead of a plugin update. This one I think is actually a pretty big one. I can check it. Nope, that's a small one. I can do it. Okay. All right. So let's just say that I want to add Firebase support to my camera app. Okay, because I already have it here. So one thing we want to do is to go to build, and when we release the app, we have to generate the one with the signed APK. So I might as well set it up here. I'm going to use test0 as the alias. So these are the same passwords that I used last time. And now, once I set it up once, it's going to remember that. Okay. So now we can use this identity, the package edu.losrios.w0006887.camera1. We'll use this as the package name in Firebase. So now we'll specify that over here, edu. Oh, okay. So I don't even have to do it like this. because if you read right here, get started on Android faster by clicking Tools, Tools, and then Firebase in Android Studio 2.2 Plus. So that's the easy way to do it. So let's go ahead and try it here. I know it works because I did it already once with my other app. So you go to Tools and then go to Firebase. You just click that option or click that menu item. And it will give you several options here and ask you, okay, which one do you want to use? So right now we are focusing on authentication. So you click on the expansion symbol for authentication, and then it will ask you, okay, under the authentication, it will give you several options. But the first thing is we need to connect the Android app to Firebase. So you click this button here.
And you had to have the sign thing before this will all work, the sign. You did the signing of the app first, is that what you did?
Right.
And
Yeah.
that has to be done before you do this.
If you don't do the sign in first, then the app will only be using an authenticated user's permission to access the Firebase. So that's why it is probably better to establish the authentication piece first, and then establish the database side.
Okay.
Yep. And then here I have to be consistent and use 2016 Spring, I think. Oh, no, take it back. This is the other browser. It just randomly picked one of the instances of the browsers. That can be a problem. Okay, let's see whether this will throw everything off. Okay. Wrong password. There we go. Okay. So Android Studio would like to blah 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 blah, and you're not even given an option of which one you can deselect. So the only way you can do it is to deny. So I'm gonna allow it. Okay. So right now we're back to Android Studio. Android Studio is now going to say, do we want to create a new project, Firebase project for camera 1, or do we want to use one that is already in existence? And that's what we want to do, because we just created test 2 as a Firebase project. But if you want to create a new project just for this Android app, you can do that as well.
So you can go the other way. You can do the Android
Right.
app, sign it, and then create the database.
Right.
Implemented, yeah.
Yep. So Google tried their best to integrate their products, but it's just starting to get integrated. So the tools is good, but not. There's some inconsistency amongst the various tools and the web pages and the descriptions, but they're actually trying very hard right now to get all of these products to integrate and work with each other. So connect to Firebase. So what this would do is Android Studio would automatically upload the SHA1 fingerprint and do all the other stuff that needs to happen. So right now it says Firebase project created and connected locally to module app. So now we are on to the second step, add Firebase authentication to your app. So this part can only be partially automated, but not entirely. But it does tell you what you need to do. So what we need to do is to add specific rules to Gradle. So we have to use, it will automatically do these changes for you. So at the top level, at the project level, the Gradle build.gradle file will have a class path to com.google.gms, Google Services, and then at the app level, it will add the dependencies to Google Services as well as Firebase-auth. So all of these things are done automatically. You just have to click accept changes, and it will do all the changes to the Gradle files, which is great, okay? Because otherwise you have to manually go in and change those, which is not a big deal either, as long as it tells you which files you have to change and how to change those. Okay, so so Gradle is redoing its thing after the inclusion of those particular lines. So now it says its dependency is now set up correctly, And this is the assistant inside Android Studio. It gives you all kinds of suggestions of how to write a code, okay? But I find it really kind of difficult to read the documentation when my screen is already small to begin with. And then I need to read this and do the coding and also, do some other stuff at the same time. So I would just go to the web browser and look for documentation over there. Okay, I have a project already completely set up, so I can show you the code when I get to that project. This is only to show you the initial steps in Android Studio to set it up so that it is now connected. Okay, the infrastructure is done to connect the app to a Firebase project. Is that okay? So I'm not going to do any coding in Camera 1 because it's just a test, okay, just to show you how to make that association. But then I can open up my actual app that has everything set up already. Is that okay so far? Okay, all right. Okay, so I'm going to close this project. Okay, File, Close Project, and go to the shared folder for this class. I just uploaded a program this morning. It's called testdb.zip, and of course I'm not seeing here. I think if I refresh it, it will see it. Yep, test FB for Firebase. So there we go. We just download it. And this one may have a little bit of a problem because the key that I used was the one from home, which has a different key store file. So it might have a little problem with from that perspective. But I can at least show you the code of how to make it work. So we'll go ahead and zip test fb.zip, and then inside Android Studio, we'll go ahead and import that project. It's called test FB. There we go. So it's unlikely that this will work here because the key that I have associated with this app is from my home key store file, which is not the same as the one on my drive right now. So it probably won't work, but I can at least show you the code. So the code is already here. You guys can read the code. It's unlikely that it will compile and actually run because of the key issue. And you can also go back to my notes, module 0274, which includes the notes of how to do this part. So we are done with section 3.1, creating a signed shell app. We are done with creating a Firebase project. We're done with linking the Firebase project to an Android app. And this is just a small discussion of why it is nice to have a provider like Gmail or Facebook or GitHub, so that people don't have to create new accounts over and over again. And this part here explains the sequence of events to use Google Sign In, because the code itself is definitely can show you that. But in the text here, I'm just describing step by step how it is done. And then section 5 is, I think, the more useful one because it shows you why it is so convoluted. Okay, so let's go back to the code first inside here to show you why I said it is kind of convoluted. The first thing we do is inside the onCreate method of the activity. So when you look up the onCreate method is right here. This is the onCreate method, which is pretty much the first instance you have some control over your app when an activity starts. Okay, it's with the onCreate callback. We have the usual stuff. Okay, the first two lines are the usual stuff, calling the superclass onCreate method, setting content view based on the layout. Okay, so we just start up a screen, no big deal. So this is where we have the custom code the first thing we do is we get an instance of the Firebase. I'm not sure whether the auth is authorization or whether it's authentication. Okay, I'm guessing it is authentication because that's what we are trying to do here, is to get end user authentication. So at any rate, we create an object of that particular class, but you don't say new because you have to get an instance out of the class static method itself. So I stored it as m_auth because I'll need that later on in several places, or at least one other place. The second thing we do is we set up a listener, and this is one of the things where it is really kind of cool because with a Firebase database, it can notify the app back when something has changed with the Firebase database. Okay? In other words, if you're watching, you can basically be watching certain nodes of the Firebase database and basically say, okay, if something happens to this node, if somebody changes it, if somebody appends something to it, if someone deletes it, let me know about it. I want to know any changes to this node. Okay? Then you can have the callbacks. Now in this case, it's not for the individual nodes of the database, it's for end users. Okay? If somebody signs in, you want to be notified. You want to be notified. If somebody signs out, you want to be notified. If somebody changes user identity, you want to be notified. So this sets up a listener so that you can be notified of any changes to the current user. Is that okay? All right. And then we proceed to a subroutine called Google Sign In. So this one does set up, okay, when you expand the code, it sets up a callback method. So on/off state changed is a callback method. So it may not happen right away. You're just saying, okay, if something happens, let me know. The next one is Google Sign In, which is just a subroutine to do one little thing. This one sets up GSO, which is a Google Sign In option. So to set up Google Sign In option, this is the code to do it. And it is very interesting, okay? It is very interesting because the way we do this is the sign up options is based on the builder. So the builder is going to create a Google Sign In options object. And in this particular case, I will need to access two things. I want to access the ID token of a Google identity. I also may want to access the email address of the Google identity. You can stack more things here too, okay? If you want to know the actual first name, last name, mobile number, and everything else that may be associated with a Google identity, you can stack more requests here. So every time you want to add another thing, so if you want to get the text SMS identity of the same Google account, you can put it here. But that means the end user may have a reason to reject your request, because when the actual request is made, potentially a screen will pop up on the phone and ask the end user, do you want to allow this app to have this kind of access to your identity? And the end user can look at that list. If it's really long, like, nope, not going to do this, okay? These ones will not trigger that screen, okay? So the email address itself and also the ID token, which I'll talk about a little bit later, do not trigger any type of end user action at all, okay? And then the last call is a build, because this is all based on a builder. So you're creating a builder and then immediately use the builder to specify the request, or the sign-in request itself is going to it will need access to the ID token, will need access to the email address. So the last one is a build to actually build the sign-in option itself, and we store it into my private member called GSO. And that's the only thing we do in this particular subroutine called Google Sign In. I should say set up Google Sign In options, but that's basically what it does. And then we have to set up the API client. Okay, so the API client consumes the GSO, okay, because you can see in the creation of the Google API client, it is consuming GSO as a parameter as one of the methods. Okay, so once again, it is based on first creating a builder object. Okay, so first you create a builder object. Once you have a builder object, then you tell the builder what you want with this particular API. You want to enable auto manage, okay, fine. You want to add which API do you want to use. So this part explains why the reason why we need add API is because Google API can support a whole lot of things. Okay, if you want to have access to your Google Drive, it's a part of the Google API. If you want access to the Gmail itself, it is a part of the Google API. So in this case, we just want the Google sign-in service as the API that we are accessing. So we're only adding that into the we're only adding sign-in API with the option object that we have just set up in order to tell Google API client what kind of API we will be using with this particular client. Are we doing okay so far with this
So we want the
picture?
API to get the email address and to get their.
To get Google sign-in. And then the Google sign-in identity, of that identity, we only need to access the email address and the ID token.
And it resolves all this here.
Yep. But nothing, there's no communication done here either. This is just building up the API client, which is an object representing the client side of using Google API. But no communication has happened just yet. Okay, we can tell there's no communication happening just yet because there's no callback. Because anytime you have something that triggers a web or internet or network type of communication, there's always a callback involved. Because otherwise it would take too much time. Remember, all of this stuff is being run in the main/UI thread, and we don't want anything that would take a large amount of time. And there's no telling, depending on routing resources, depending on many other factors, how much time it's actually going to take to get through this process. So we know for sure that there's no communication happening right now. Okay, we're just setting up the client-side communication back end to talk to the API server. Okay. And with all this discussion of API, what is API? I'm just double checking, making sure that this term is understood.
Application programming interface.
Yep. It's application programming interface, which is a pretty generic term these days. Okay, it used to be kind of more specific, but these days it's a lot more generic. So when we use the classes in Android, packages, it's a form of API. But this is another form of API where the API is referring to HTTP requests, okay? Specific ways that a client can query a server, and the server has a specific way of replying to the query. So that interaction, that agreement, the standard, is also called an API, except in this case, it is an API that is based on communication protocol and standards, as opposed to a class that we have been using in this class. Is that okay? Right? Okay. So once we set up all the options, with the builder, then the last call is the build method of the builder object itself, which actually creates an object of the class Google API client. Okay? And that thing is done. It is just sitting around because we have some other things to set up first before we can actually use that. The last call, or the last thing we do inside the onCreate method, is to set up a button. Okay? So the button looks like this. Let me show you what the button looks like. And we're going to go to design. Yep, there we go. So as it turns out, there is a button as a system resource that looks like this. Okay? The Google sign-in button. You cannot drag this in from the palette on the left-hand side. So there's specific instructions if you read the instructions how to do it. If you go switch back to the text side, it is this thing here that creates that button. Yep.
Did you have to put that in, or was that?
Yeah, I have to put it in manually. Yep. Mm-hmm. Because it's part of this package. It's part of the package that we just told the Gradle file to include. It's part of the GMS. I think GMS probably stands for Google Messaging System. I don't know. Well, let's look it up. So we
And
need-
the find view by ID sign-in button is getting or responding to that button.
Right. Okay, so GMS stands for Google Mobile Services. Okay, there we go. It's a collection of Google applications and APIs that help support functionality across devices. And that's a very major part of what we are doing right now. Okay. All right, so right now, if I don't do anything, if I don't click the button at all, this is all that we have done so far, okay? So there has been no contact with the Google API server. There has been no contact with the actual Firebase, project itself at this point, okay? In fact, at this point, the end user is not even authenticated yet, okay? There's no authentication of who is using this app. So it's only when the button is clicked, then we'll do something. Okay, so when I expand this code, this is a typical click listener callback, okay? And the only thing we do with the callback is sign in. Sign in is one of the functions. Okay, so Alt Enter. Oh, yeah, okay. Control click. There we go. Okay. So when we go to sign in, this happens only if the end user clicks that button. Then we'll do this part here. What do you think is going to happen next, just from reading these two lines of code, line 46 and line 47? What do you think is going to happen next? What is it setting up? Just look at the type of the objects that we are dealing with.
It's using intents.
It's doing something with intents, and when we do something with intents, what usually happens next?
It asks the user permission.
Right. But it is somebody else's activity. This is not my
Right.
activity.
We're
This
gonna
is the
suspend.
GMS, the Google Mobile Services, activity that is going to handle who are you, what is your Google username, and what is your password. In other words, my app never touches the actual username nor the password.
It's going to ask the Google Gmail.
Yep.
Whoever
Yep.
manages Google account.
Yep. Okay, so this basically says, Google does not trust my app at all. You're not going to know the username. You're not going to know the password, which is great. Okay, this is the way we like it, because then, if something does happen, and people want to sue your app and go like, oh, you hacked my password. You got my username and my password. You can show them the source code and go like, nope, there's no way I can actually get your username nor your password, because this is all done by Google's own activity that you just say, okay, we'll use that activity to do something. Okay, but you can also see one thing that we have created earlier on is consumed by this particular thing. Remember the Google API client object that we created earlier? It is consumed as a part of the intent. Okay, so this is how you tell the Google sign-in activity of, what do you intend to do with this? Okay, first of all, okay, the Google API client object is going to say, we want to use the Google sign-in API. Okay, remember that's a part of what we specified. Okay, is that we want to use Google sign-in. The second thing is, since we want to use Google sign-in, what kind of options are we requesting? Well, remember the two things, the two request stuff that we specified with the GSO, the Google sign-in options. We want to get the ID token, which is automatic. That's kind of like the bare minimum that you want to get. And we also want to get the email address from the Google identity. Those two things, which is a part of the GSO got integrated into the Google API client. So now we are passing this Google API client object to the intent, so that when the Google supplied activity starts up, okay, it knows exactly what kind of thing we're requesting. And that is going to do all the communication backend stuff, okay? Not us. We just offload it, delegate this to the Google activity and go like, okay, you do whatever you need, okay? But when you're done, let me know of the result. And that's why the next line says start activity for result. Because if you do not start it for result, then you have no idea when it's done or the result of using that activity. But in this case, we do. When you use start activity for result, you need to give it two things. One is the intent itself, which is set up by the first line, the previous line. The second thing you need is to give it a unique integer, and I just randomly pick an integer here. Okay. Yeah, basically it's just your own way of identifying when we have a callback. Okay, so whose response am I processing? Okay, so this is just to identify. If you have 20 different intents that you want to be able to start from inside this activity, this helps you identify whose result am I looking at. That's all. Is that okay? Because when they're all done, they want to come back through the same callback. Whenever an activity with a result is done, it's going to come back and call the same callback function. So within the callback function, you have to look at the result code and say, oh, so who initiated this? What is the identity of the activity that is just completed? Okay. So at this point, right after line 47, your app is going to sleep because your activity has just called upon a new activity, which is now loaded into the front end, and it will ask the end user for the password, identity, the password, and then do the actual communication, talk to the API, the Google API server, negotiate, get back whatever is needed, and then when everything is done, then it will come back to your app and go like, I'm done, and here's the result. Okay? So that, yeah, go ahead.
The whole thing was initiated with the start activity for result.
That is correct. Yep.
And you're saying there's another place we're going to handle the
Yes.
return? Okay.
Yep. So that's all the way to the end of this file. So to the end of this file, we have on activity result, which is the callback corresponding to something that you asked through an intent is done, and you ask for a result. That will come back through this particular callback. On activity result is a callback just to handle that. Okay. So the first thing we do is to handle the super class, on activity result to get some, some of the bookkeeping stuff done. Yep.
That could be that they signed in, or it could be that they didn't sign in, right?
That's correct. Either way, it will come back to you.
Okay.
Yep. Okay, so the first thing we do is a switch statement because I know it looks kind of silly because that's the only case here. Okay, so what is the point? Because you might have some other start activity with result call somewhere else within this activity. So this will help you distinguish whose result am I processing right now. Okay, so I'm using this integer to identify. Oh, now we're dealing with the sign-in request. Okay. So if we're dealing with a sign-in request, then the first thing we do is we are going to get the sign-in result, which is a class name. And you get it through the auth, which is a class. So this is a static, this is an embedded class of auth. And then within that, it also has its own static method called get sign-in result from intent. Okay, and I guess I don't really have to explain what it does because the name of the method is almost a complete sentence. So what it does is it extracts the sign-in result from the intent. Okay, as the name implies. How do we get data? Data is a parameter. Okay. So you can see on activity result has 3 parameters. It will give you the request code, which is corresponding to the integer that we defined here. It will give you a result code if there is one that is useful. In this case, it's not useful to us. it will also give you an intent, which is based on the original intent, but potentially with other things attached to it. So we would pass that data, which is an intent, to get sign-in result from intent. So we now end up with a result, which is of the type or of the class Google sign-in result, and then we'll offload the processing to another subroutine called handle sign-in result. So let's go to handle sign-in result and find out what it does. So here's handle sign-in result, which takes on one single parameter of the class Google sign-in result. So here we can tell whether the result was successful or not. It's only at this point that we'll go like, okay, did we sign in correctly or not? So it can be yes, we did, or not. So if the result is successful, we will go ahead and finish up the rest of the code. Otherwise, we'll just update the user interface and specify, nope, we did not sign in, which just displays a no in one of the text views. Okay, no big deal. Okay, are we still doing okay so far? Okay, so at this point, so just let's say that we got to the then branch, okay, which is this branch here, so that we are now ready to execute these 3 lines of code. What have we established at this point?
Well, they went out and they signed in using their Google account.
Yes.
Either they signed in or they didn't.
Yes.
Now we have to discern what to do with it.
Now we know they did.
We know they did because we got to the then branch, which means
Okay.
it was
No, they
successful.
did. Okay.
But at this point we only have a successful authentication, which basically means somebody signed in and now I have a Google identity. Is it related to my Firebase? Not yet. Okay? We haven't done a single thing with Firebase at this point. All we have done at this point is to ask the end user and say, sign in and give me a Google identity. And this is where we are at this point. So we haven't done anything to link that user identity to Firebase.
So we haven't even linked the app to the Firebase? Or?
We have not linked the app nor the end user to the Firebase yet. So the Firebase project is still sitting up in the server, having nothing to do. Not even knowing this app is about to use it.
Nice long chain, huh?
It is a very long chain. It's very convoluted, but there's a good reason why it is like that. Okay, so the first thing we do is we use an object here. Okay, so this is interesting. We look at the result and then we create an object of the class Google sign-in account, and we just call it account here. The only reason why we need that is just to use it here. I suppose we can just copy and paste this code, copy this, paste it into here, it will work just as well. Okay, but this makes it more clear that we are actually passing an object or reference to an object of the class Google sign-in account, which probably is not very complex because it only contains a token. Okay, we'll talk about what a token is and why it is important. Because you might think, hey, from the name of this particular class, we have everything that we possibly can want to know about this account. Okay, when was it first registered? What is the gender of the owner of this account? What is the first name, last name of the owner of this account, and so on and so forth? That's not the case. Okay, because basically what we have at this point is a token. It's a long number that seems to be kind of random, gibberish. Okay. No.
If you command click the Google sign account, control click it.
Control click it.
So it's got a lot of stuff in it.
It's
It
got
gives
a
you
lot
the
of stuff.
token, the accounts, the given names, the blah 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 blah. So it looks like it's a bit more than just a token. It's a representation of all of those things, right?
It has the things that you have already requested, but of the things that you have not requested, it's not here.
We'll scroll down. So you can get all these guys. Keep going. And then there's an interface down here on the bottom, which gives you to the there you go, all the other doohickeys. But they're not in that token.
They're not in there.
That token, but that's it. It's
Yeah.
it's an abstract class, or not an abstract class, but
It's
It's concrete.
it is not, yeah, but all of these things can be null,
Sure.
which means it's not there yet. So unless you requested those specific things, I did not ask for display name. So when I try to access the display name of this account, it's not going to be there. But you're correct, it's not just the token itself, it probably has already populated whatever you requested when
Inside that entity.
in your GSO, if you say request display name, then it would have populated display name. Okay, good. Okay, so I updated UI just to say yes, we got it. And the rest of the work is done with Firebase auth with Google, which is just my own method, so that I don't have to put all the code into here.
So you could have said at the update UI, we could have said not just yes, but welcome tag,
Yep.
because we have your email address.
Right, because at this point we only have the sign in, but we have not
Connected to anything, but we are
exactly.
signed in.
We are signed in. Yep. Okay, so let's go to Firebase auth with Google, which is fairly easy. Okay, so this is finally how we make that association between the Google identity in the form of the account here and the Firebase auth object that we created in the first place. Yep.
Okay, I'm confused because I thought the app associated with the Firebase, but now you have a user.
Yes, so there are two associations. The app itself is basically saying how should I put it? The app is acting as a client of the Firebase server. So the app has to identify itself and go like, yes, I am one of the many applications or one of the many clients that is authorized to talk to you. Okay, but that does not associate the use of the Firebase with a particular end user.
I see.
So it's the first gate that needs to open first, is to say, okay, can this app even talk to me? I'm the Firebase server. So whenever somebody is trying to initiate a communication to me, I will first have to say, who are you? Oh, I'm Joe Schmo. Let me check the list. Joe Schmo is not on the list as an application. I'm not going to talk to you. Okay. On the other hand, if it's one of the mobile apps that is supposed to use this particular Firebase project as a backend, I look at the list, I check the fingerprint, the SHA-1 fingerprint that I have stored against the certificate of the application, go like, yep, it's a match. Okay, you may talk to me now.
So if I have data that I want all users to see, I don't need this sign-in. It's only if I have data that's
That is
specific
correct.
to a user.
Yep. So this allows you to associate a particular end user to the use of your database. Okay, so if you kind of vaguely, okay, let me give you an example and
So
see
can
if
they access the Firebase without being logged in?
they can, but but then you'll be using the default permissions.
Yeah,
So
but
that's
they'll
the-
be seeing the same data. In a
Right.
sense.
And the default permission is you can only see something after you are authenticated. So you need the authentication piece regardless, unless you change the permission rules to say that you can access anything, or at least you can read anything, even without first authenticating who the
Like
user
if I had a list
is.
of earthquakes or something and then I kept
Right.
them in my Firebase, I don't
Yep.
really care, go ahead.
Yep. So you can set it up that way.
So we
too.
have to authenticate the app, but we don't have to authenticate the user.
That is correct. Yep. So this is the last piece that. So first of all, we get the credential from the account itself, okay? Because you can see the account, the parameter is only used here, and the only thing that we need with the account object is to get the token, the ID token. So with the ID token, we create the credential, and then the credential is of the type auth credential, which is a part of the Firebase package. So with that, I can now actually go ahead and do a second sign in, and this second sign in is not a Google sign in. This is the Google identity that is already signed in, signing into the Firebase project itself. Okay? And this is a request. Okay? This is going to initiate a whole bunch of network communication. When it's all done, then your callback is going to get called with on-complete. And then at this point, I'm not doing anything. I'm just using the toast, which displays a brief message on the screen that go like, yes, we got it. We have finally associated an end user identity with Firebase. So now anything that requires specific end user identity with this Firebase database, I can now start to do that.
So you didn't connect to this Firebase.
Nope, I did not.
Until you used the user.
Right.
So it is a one-step. I mean, we log in Google, then we connect user to project.
Correct. Yep.
How did you set up your user on the Firebase side to know that that's a valid user?
That's a good question. Okay, I can show you exactly how it looks like on the other side. Okay. So we want to go to one of the browsers, the one that is incognito. It's not this one, it's this one. Okay, there we go. This one doesn't have anything yet, okay? So let me sign out of this one and sign into the one that actually has something. And that's going to be, it's going to be the fall one. Dr. Tag 2017 fall. Nope, 16 of course.
So nobody's registered through next year's email?
That would be kind of interesting. That would be funny. Nope, nobody has done that yet.
That's nice of them.
Nope, that's not the one that I used. Let me sign out again. Is this the spring one? You can definitely feel the problem of having too many accounts now. Yep, it's this one. Okay, that's the one. So I click on the project, and it already has. It's starting to collect usages already. I do not have to pay a single thing because I'm still way below what I need to do in order to pay Google to do this. And this is the interesting part. It shows you the active users, and then you can look at where's my list of users. Good. If I go to authentication, there we go. Okay, so it shows that I signed in. This is from a different account. Okay, you can see it's oyont@gmail.com. It's not Dr. Tag 2017 Spring. Okay, so I use an entirely different account to sign in using Google Sign In. It shows you when the creation date is not the creation date of my Gmail account. The creation date is the first time this Gmail account started to use this Firebase project. Yes.
This would be your admin account, right?
Yeah, this is the console of Firebase.
Okay.
So as a developer of this Firebase project, I can sign into the console, and now I can see, okay, who signed in to connect to this Firebase project. Okay, so now we have one single account created for this particular Firebase project.
But there could be millions.
It could be millions, exactly. I haven't set up any rules for this particular database, so we're running out of time. So I time it just right? We're almost done. I did not even get to the part where I explained why it is so convoluted. The reason why it's so convoluted is because of the lack of trust of the app itself. The app itself cannot see something it is not supposed to, and yet you have to coordinate between, okay, here's sign in, Google sign in, here's Firebase. You have to do this coordination. So how can you do this coordination without actually knowing the details of the account? So you have to use the token. So the token is internally how Google identifies a particular existence. But a token has a lifespan as well. so it only lasts so long. So that way it lowers the exposure risk, so that people cannot just say, I can just copy your token and I can start to pretend to be you. That won't work either. Okay, so this is what we see when we set up a database. Just for those of you who are planning to use Firebase, because it has got a lot of interesting stuff, you might want to look at rules. Okay, so data is interesting, rules is useful as interesting as well. So this is the global rule because it's at the root level. So what it says is who can read. Okay, as long as alt does not equal to null, you can read. So that means anyone who is authenticated can read from the root level and down. Who can write? Anyone who is already authenticated. Okay, so I'm not even checking who it is. I'm just saying as long as you're authenticated, you can read and write from the root level of this application, which is definitely not safe.
So when I said before, like if I had an earthquakes and I listed them, I would just say read anybody.
Yeah, you can then turn this into true.
Yeah.
Just say true, because this is a condition. Now
So
it
that
doesn't.
makes it public, and then we're just all we have to do is set the project up, and then.
Yep.
Okay, so if I want users that can enter data, but under a small set, and I want a lot of users that can read, that's exactly what you're saying, right? I can set the read.
You can set it up, and it has
Only set my 5
examples.
users up here.
Yep,
whatever,
so-
and they can write.
Yeah, so if you click Learn More, okay, it will give you like step-by-step, guidelines of how to do this. So it has simple rules. Okay, simple rules is exactly the one that comes as a default. It is essential you configure these rules correctly before launching your app, because the way it is set up right now is definitely not safe. Okay, because anyone who's authenticated can do whatever with your database backend, which is not good. Okay, so it talks about how to secure your data with security rules, and there are several one of these. Let me see which one I want to use here. So you can set it up so that the dot read is based on, in this case, based on time. It just has to be a condition. It only has to be a JavaScript expression that returns either a true or a false value. That gives you a lot of options. Okay, gives you a lot of options. So you can use time to specify whether something is readable. You can also use validate, okay, which is cool. But what you were asking earlier has to do with referencing a particular end user. So you can use false to basically say nobody can read it at all. So completely shut it down for reading purposes. Rules are not filters. Keep going, validating data. Keep going. Okay, so this is starting to get more interesting because the dollar symbol refers to internal variables that you can use. So this rule basically says, okay, under the under the room's key, it has its own key value pairs, right? And then within each key value pairs, it's basically saying if the key is something, it will automatically instantiate the variable room underscore ID. Then you can use room underscore ID as a variable inside the permission part, the rule part, and say that this room ID needs to contain public. So in that case, basically it means the room itself, whatever this room name is, needs to have public as a part of it.
So that says inside the rules, there's a key value called rooms.
Yes.
And inside the rooms, there's a key value where it's the translated from room ID to, I don't know.
Right. It's instantiating the variable on the fly as it needs to, in order to evaluate whether.
So it's like math 127, and
Yeah.
then it turns around and says math 127 contains public.
Yep.
Okay.
So that gives you a lot of flexibility. But the best part, okay, anonymous chat, okay, secure user data. So this part is the most interesting part, because what you do is you can use the internal variables, or in this case you can use a user ID, and you compare the key, which is a part of the database itself, to the ID of the authentication. So you have to structure your database so that the user ID, the auth UID, is used as the key of the key value pairs. Then you can use these specific rules so that whatever is under this particular thing can only be accessed by somebody who's authenticating as the specific key, which is the UID of the auth package, of the auth object. And that UID is guaranteed to be unique across providers. Do you guys remember that discussion on last Wednesday? So if I have an account with Facebook, an account with Gmail, and an account with GitHub, those 3 accounts will all be different. Or I should say they will all have different UIDs when I authenticate. Is that making any sense?
Just like you keep doing every time you log in with a different
Yes.
key.
Yep. So this is how you can secure data so that only a specific end user has access to that.
So I'm not sure I'm understanding that. Is it, how does it, is it in the database that has the username that's operating?
When you create this particular entry,
Yeah.
you would create it with auth.uid, but using Android code in this case.
Yeah, there's more entries in the users table that are other user IDs, but when this user can write an entry to this table and that'll put their user ID in as a key. Right? That's what I
Yep.
see this as. So the first entry will put the key in, so then you see rules users Keith, because that happened to be my authentication ID.
When you
And
create
then only Keith can write to that row.
Oh,
Rules users Keith.
right. In other words, every single time you access something inside the user's hierarchy as a key value pair, in order to determine whether you have access to the value of a particular key value pair, it would evaluate, or whether you have write access in this case, it would evaluate this particular rule and compare this thing, which now turns into a variable, against the UID of whatever user that has authenticated into the use of this Firebase project.
This essentially makes it so a user can only write their data,
Yes,
and no one else can write their data.
correct. Now, this rule does not specify anything about .read, which I'm assuming has a particular default. But the thing, if you read these documentation sequentially, you will read the part where it says the parent's permission or the parent rule setting overrides the child permissions. So once you set up a hierarchy to be read only, then it sets it up for the rest.
Where you can't upgrade it. The child can't upgrade his permissions.
Right.
Least permissions from the parent down.
Right. So it is. So you do have to kind of read it in a certain way to make sure that you understand, the implication of what happens when you specify. Okay, here's the parent; it has got its own rule, and then here's the child with its own rules too. So how would those rules interact? So you got to read about that part. So when for reading, it says as long as it is authenticated and the UID is whatever the ID is. Well, how is that different from this one?
Well, that one's using absolute identity. That one uses the equal in JavaScript.
Right.
The other one's saying is that, I can't remember which one's which, but.
Okay, this one says must exactly match. So does that mean this one not exactly match?
Well, they changed the key too. One's using the variable user ID, and this one's using the variable UID.
But that's just how they call this thing. I mean, it's still the same thing. Because whatever this $UID is just whatever appears to be here. Whatever this $user underscore ID is just whatever is appearing here. And how come this one does not
You
have?
have to have, it has to come into an existence somehow, right? I mean, it's going to be in the REST call or something where you'd have user ID, or somewhere internally we have to give it meaning.
As an example, one common pattern for storing user data in real-time database is to store all of your users in a single user node, which is the same thing here, whose children are the UID values for every user. Okay, fine, which is the same way over there too. If you want to restrict access to this data such that only the logged-in user can see their own data, your rule would look like this.
I guess the difference is between the read and the write.
It doesn't make
I guess
sense.
as a writer, you must already have an off. Because that's the
Doesn't
only
make
thing they
sense at
change.
all. Here's an example rule that uses the auth variable to ensure that each user can only write to a user-specific path. Okay, doesn't.
What's that extra condition in the read? Authorized not equal to
Yeah, just make sure that it's not a null value.
Before
the other
you
time they
use
didn't care,
the
they just
UID.
used it.
Yep. So that means the write rule itself
I guess
is not
they
safe.
null, which is right into null.
But then the difference there is the equality. So one is the triple equality. I don't know
Right.
JavaScript that well, but and the other one's the double equality.
The triple means that it won't change type, right? So JavaScript likes to convert automatically.
Oh,
Triple
okay.
means don't change type.
So the abstract is the equal and the strict equality.
Okay, so strict equality is used by array prototype index of last index of a case matching. Okay. Strict equality. True. Okay. False.
And neither value is implicitly converted.
So it doesn't do any casting.
Right.
And then the other one would automatically cast.
Loose equality.
Okay. After converting both values to the same common type, as opposed to the other one which does not convert.
Yeah, so you have like a string 8 and a number 8,
Yep.
they'll make it equal if it's just 2.
Yep. Which adds more to the mystery because
Why is this different?
because then it would fail if it is required to use triple equal here. If it's okay to use triple equal here, then there's no need that it would be okay to use triple equal here as well, because it means they have the same exact type. And then the other problem is with this one, it checks that auth is non-null first, which means this one may actually cause an exception, because what if auth is null at that point? Then you have no way to refer to UID of a null pointer.
Well, it's strictly equal anyway, so it would fail.
It would
I mean,
automatically.
I don't know if it threw an exception, but it's
That's
just not legit. It's not.
It's not consistent, okay? They may both work equally well, okay? But you can definitely tell the same document was written by multiple people at Google.
It appears that way.
So if you don't log in, you end up with a null, right?
If you do not sign in, then auth will be a null
So this is
pointer.
saying I won't write that this.
Right. This will definitely fail to compare. The compare itself would definitely fail, but they could have used exactly the same logic here, and that would fail too, because null is definitely null, so that auth is not null would fail, and since this is a conjunction, the whole conjunction is going to fail.
Right.
So I just don't understand why they chose to write it in one style, and then change it to another style later on.
Can you make an authorized user null?
Yeah.
If
Sorry?
You could write, if you have a user of null, then it will write to a null area in the database.
No, you can if the auth itself is null, then unless you set up the rules where there's a place where somebody does not need to be authorized to write something to it.
Mhm.
Otherwise, there's no way to write to it.
Okay.
Yep. So I guess on Wednesday, not the next Wednesday, but on this Wednesday, we're gonna get into the actual database part, and it's called a real-time database because it's not designed for batch operations. And then the other thing that I talked about a little bit earlier today is this is not relational. So what if you want to do something that is traditionally done by a relational database by joining multiple tables? So what do you do when you only get something like this, which is basically a simple hierarchical key value pair list? That's it.
So that pretty much equate to JSON?
Yep,
Really?
that's exactly what it said.
Okay.
That is exactly what it said. If you go to go back all the way to the guides and look at oh, I cannot remember exactly where I saw that, but if you go to the real-time database and just go to get started, I think it says right here. These are Android specific already. Let's go to the general introduction. There we go. There's somewhere in here that said exactly what you said. This is basically a JSON property list.
Okay.
Hierarchical up to 32 levels deep. That's it. So they do have suggestions too. For those of you who are already familiar with a real relational database, they do have suggestions of what to do if you want to join, quote unquote, perform a table join operation. It tells you exactly how to do it, but it does it by replicating keys at multiple places, which puts more burden onto the code, so that when you update something, there'll be multiple places to update.
Accountants love that. Accountants love that.
Multiple places, checksums, right? You have multiple ways to make sure that there's no discrepancy whatsoever. Yep. But they do have suggestions of how to handle cases where you need a table join operation that is traditional in SQL, and how to do it with this. Now this relates to big data as well. How many people have heard of that name, big data? Okay, what does it mean? It can mean several things.
It means more data than you can hold on in your computer. You need more than one computer.
Exactly, more than one relational database to be exact. Okay, so when you go to big data, it tells you about how much data can we reasonably store, retrieve, and manipulate and control using a relational database. As it turns out, there's an upper limit of how much you can do in a practical sense. Now, the problem with a relational database is you have all of these join operations. With a join operation, it is really hard to split the job into multiple parts and have different servers to different parts. Why is it so difficult with a join operation to say, oh, we'll just have a cluster to do it, and this computer handles a part of it, that computer handles another part of it? Why is it so hard when you have to join two tables in a single query? What is a join operation?
You have to have both access to both tables at the same time, in a sense.
Yes, and all the keys.
And all the keys.
And all the keys. So that makes it kind of difficult to do it in a cluster. So it's not very scalable. That's the problem. It's not very scalable. And also in a traditional database, it has to do with how data is stored. When you create a table in a traditional database, what do you have to supply to the database manager in order to create a table? What do you need to specify? For each individual column, right? You need to tell how many columns, how you want to name the columns. But on top of that, the type, exactly. So can you just say, oh, this is a string, and I have no idea what is the maximum string length. With a traditional database, you cannot do that, right? You can say the maximum is up to 600 characters, but it may be less. That's okay. It's a var chart, right? It's a variable character array, which means this is the capacity reserved for this much, but I might only use this much, as opposed to I'm always going to fill up that much. Okay. That has limitations, because what if people want to upload pictures? What if people want to use blobs? Okay, with your database, you can't handle that very efficiently. So big data is basically saying, okay, the traditional way of doing relational database runs into all of those limitations. And as a result, people use big data, which is a different idea of how to organize data. It's a very simple thing. It's just key value pair and potentially hierarchical. And only using those very simple mechanisms, this is how we store data now. So the bigger question is, but then how do we retrieve something? How do we do a traditional select statement that has inner joins with multiple tables so that we can use keys here? Okay? And they have tricks to do that.
It's all in the names of the keys.
It's the naming of the keys, exactly. Yep. And because they have very efficient way of indexing. So if you have multiple, and you can also index the values inside the value of a key, you can index that as well. So you can do a reverse index based on the value of an item. Okay, so it's interesting because they have to flip everything around in order to make it efficient to handle a huge amount of data and make it so that you can split it off. You can have, okay, we'll have this server to handle this part, this server to handle this part, and this server to handle this part.
Keys, that server to handle those keys.
Exactly.
Yeah.
Because you can replicate that. You can replicate the keys onto multiple servers and just say that you handle this part, you handle this part, and you handle this part, and they don't have to talk to each other during the operation. So that makes it a lot more scalable than the traditional way of joining, where you kind of have to lock things down a whole lot. So this is the new way of doing things, and I'm kind of glad that Google has made a relatively easy to use API so that we can now all start to migrate in that direction. The upper limit of a relational database. A few years ago, I was reading an article, and it says, if your relational database is storing anything that is bigger than 8 gigabytes altogether, it's running upon the limit of what a relational database can handle. But that was an article that I read like a few years back.
Oh, because it doubles every 40 months.
What doubles?
It says here the capacity to store information doubles every 40 months.
But it has nothing to do with the storage. The storage itself, it has to do with the indexing mechanisms along with everything else that makes it very hard to handle more than 8 gigabytes of data using a traditional database arrangement.
Yeah, I'm just saying every 40 months the amount of data you're handling is just double.
The demand is doubling.
So then you're falling behind.
Yeah, you're basically saying the demand is doubling, but the capacity to handle it cannot double anymore when you're doing a relational database.
16 gig, 32 gig.
But it cannot, because it has to do with how big of an index it can handle, and also has to do with the efficiency of a file approach. Because when you look into a real database, it is still using a file approach in the back end. Okay, so it has to do with how do you allocate stuff when you insert a new things into a table. What kind of file operation has to happen to add that one new thing into the file, and how is it going to be indexed? As it turns out, there's a limitation of how far you can go with a traditional approach. In big data, just basically say, don't worry about the file backend, we'll handle it. You just tell me what is associated with what, the key, and tell me what the key is, we'll find it very quickly. And you can also do a reverse index. The document that I was reading a little bit earlier, which is this part here, also talks about, it's not specific to Android. Can't remember where I saw it now. I think it's under Learn More, but possibly not in here. Index data, that's right after secure data. It's secure user data. So it shows you an example of how to reverse and index the value of a particular key instead of indexing just the key. The keys are always indexed, but you can index the values as well. So in this particular case, they are storing the scores of individual dinosaurs. So the value of a key is easily indexed. And by specifying as a rule that you want to turn on index, and you want index based on the value of a particular item, so now you can do a reverse lookup really quickly, and you can sort it really quickly too, because once it's indexed, it is really fast to sort, because it's free, okay? So now, with this feature turned on, you can have like a bazillion, dinosaurs, and you want to say, okay, give me a list of the top 5, dinosaurs with the highest score. It'll take like this much time to execute, because the score is also indexed. You can use the score to index into this item and find out, which dinosaur has the highest, second highest, and the third highest score.
So you indexing both sides?
You can index, the key is automatically indexed anyway, but you can also index the value in this case as well. So you can specify all these rules to kind of make make lookup operations of your database more efficient.
At the cost of space, but
There's the cost of space, but
in
space
big
is cheap.
data space where we don't even know it's there.
Exactly. Space is cheap. Processing power is cheap. But being able to parallelize processing is tricky.
Time is expensive.
Time is expensive. Exactly. That's basically the bottom line. And in order to save time, you need to be able to parallelize operations, which is basically saying, okay, the amount of time to do something with 20 servers as opposed to one should be about 20th of the amount of time that one server will take. Okay, in order to be like truly scalable. And so we want to do that. And sometimes to do that, you have to replicate the data onto all 20 servers. That's cheap. We can do that. Okay? But in order to make it fast, okay, we want to sacrifice space, we want to sacrifice processing power in order to make it fast. Because Moore's law is still keeping up for some really strange reason, because every 5 years somebody's gonna say, Moore's dead.
Every
Nope.
18 months he proves himself right.
Yep. Reasserts itself. Just look at the latest processor from AMD, the Ryzen line of processors. It's for $300, it's beating some of the much more expensive Intel processors. It has got 8 cores, but it has some really interesting multi-threading support in hardware that makes multi-threading far more efficient compared to the older ways of doing it. Yep, and it's only $300.
Does it have
I think
integrated
he's gonna
graphics?
die.
Nope. Yep, go ahead.
Does it have the integrated graphics?
I don't think so, because I think it's intended for intense gaming. So it's intended to a market where everybody wants to have a like $500 graphics card and a kilowatt power supply. You turn on that thing, it's almost like a space heater. Yep. the lights all dim a little bit.
Generator.
If you have it near your legs, they'll burn your hairs off.
Mom, we need to get an electrician to to get a new breaker box. Why? Did you buy a new electric vehicle? No, but my new gaming machine needs 220 volts. And a 30 amp breaker too. Yep. Okay. Well, I guess I'm gonna stop the lecture of today. But I think this is all very interesting. Okay, unless you know all this stuff prior to this class, then you go like, yeah, you know that already.
Oh, we know it.
But just to connect, we only did the connection part today, the authentication into Firebase. So on Wednesday, we'll start to actually use Firebase to basically say, that's the easy part, okay, by the way. Okay, let me show you how easy, at least in concept, it is. Okay, so I'm going back to a command prompt here in Linux or any type of system. So what do you see here? What do you see about this part? What is that part called? It's the prompt, okay? It's just a prompt, and in this case, to be more specific, what is this part? Okay, just the highlighted portion. It's an identification, okay, which is somewhat analogous to the authenticated user to Firebase. Okay, kind of analogous. Who are you? And basically that's just who are you. What about this part here? What about this little tilde symbol that is really hard to see because the resolution doesn't lend itself. It looks like a dash to most of us. But there's a tilde symbol. What does it mean in Linux, in the command line interface? The home folder, right? It is representing a point in the system's file hierarchy. Okay. If I do an ls, I can show all the files within this particular folder. And guess what this really is? It's a list of key value pairs, where a key is the file name and the value is the content of that file. Is that okay so far? So what if I want to add a file to the downloads folder? Okay, so I do a cd, change directory to downloads, okay, right? And I want to create a new file.
So you're your first nested key. You're your first nested key. You got
Right.
32 of these levels to go.
And you can have up to 32 levels if you want to structure your database that way. Okay, so I go to downloads and I say touch blah blah .txt, and this creates a new file. Okay, no big surprises here, right? So do ls blah blah, and it's here. I just created it. So whenever I want to create a file, whenever I want to delete a file, whenever I want to query a file, I have to first cd to the folder that contains that file. Is that okay? Firebase database works exactly the same way. So there's such a thing called a reference. Okay, the reference is your current working directory. Okay, if I do a pwd, it prints my current working directory, which is where I am in the entire hierarchy of things. I can only be at one place at a time, or each object is representing one place at a time. You might be able to have multiple objects representing different places. Okay, so wherever you are at, which is inside the downloads folder of user, which is inside home, now I can say create a new node, delete an older node, or ask for the value of this particular node. That's how you use a database, a real-time database in Firebase. Yep.
So would it be like linking? So if we did have like I don't know, home user Keith messages, and I had message 15, but you had somewhere else a list of messages, messages, and in there was message 15, but would that be the same message? Depending on how we indexed it, or would it in Firebase, would they be two separate copies?
I'm not quite getting.
I'm having a reference to the same message. One, you've got it down through my users that I sent this message, and another one you have in a table of, say, all messages that have been sent. But would they be
They are
pointing to
not.
the same object?
You cannot create a hard link between nodes inside Firebase. So it's a true tree structure, which means you cannot have 2 points referencing the same thing.
So I would just reference the key from the second look.
Right.
My table, I'd reference the key of the real list of messages.
You can do it that way, yes. So that would be the ideal way to do it. Instead of replicating the message itself, you basically use the key of the message. However, you want to create a key, and that's the trick too. How do you create the key? So you just have the key sitting everywhere where you might need to reference a particular message.
Got it.
Yep. So Wednesday is going to be easier because that is actually a whole lot easier in terms of concept compared to what we did today with the authentication. So I didn't even have time to explain why we have to jump through so many hoops, why it is so convoluted to do the authentication. It is described in my notes that I have written about it. It has to do with Google cannot trust you, plain and simple. Okay. So what Google needs to do is to say, well, since I cannot trust you, I can only give you a token to represent a particular user. Okay, first of all, I don't trust you. I don't trust anyone unless they can prove who they are when they access Firebase or Google sign-in API. It's actually Google sign-in API that requires the registration of your fingerprint, not Firebase itself. Okay. So in order to use Google sign-in service, no matter from where, you have to say, yes, I am so and so, and look through your list, I am authorized to do it. Okay, so that's why you need to upload the SHA1 fingerprint to, in this case, Firebase, because Firebase in the backend connects to Google Sign-In, so it's doing everything for you in the backend. But it is Google Sign-In itself that requires your app's own fingerprint. So that's the first level of security check, is to say, are you even authorized to talk to me? Okay, do I have a record of you as one of the authorized clients to talk to me? If so, yes, okay, now talk to me. So now you want the end user to sign in using Google Sign-In. Then Google says, I cannot trust your app. You're not supposed to get the email address or the password or anything related to an end user. So how do we do it? Well, we have to set up everything, GSO, the Google Sign-In option, and then the Google API client. So we set up all of those things, and then we pass it on to a Google activity included in your Android operating system to do the actual sign-in. So the username you never capture, the user password you never capture either. When this is all done, it comes back to you, and through because of your Gary's investigation, it does come back with the things that you requested and is authorized to have. So in the case of our sample program, I asked for the email address, I asked for the ID token, and both of those things are populated. But if I try to get to the display name, I won't get it. It will just be a null pointer because I did not ask for that. Okay? So this is how Google can make sure that you do not get more than what you ask for. I don't even get to the actual distinct user ID, or maybe that is included. So now we have a Google sign-in, but Firebase is not signed in yet. Okay, there's no linkage between this signed-in user and the Firebase project. So we have to do the second one to authenticate into the Firebase project itself in order to connect a particular end user identity to the Firebase. So once those two things are connected, then all the future operations will be from the perspective or using, so the auth object is going to be populated, and then we can now start to use the UID of the auth object as a part of the security rules so that we can check and protect the content of the Firebase real-time database against unauthorized access. So there are all of these levels of security checkpoints to make sure that everything is safe, and in case your app itself is hacked, you can only get so much out of it. And that's why it is so convoluted. All right, so I think we're done for today. It was definitely a fun weekend. Digging this up, it's like, okay, this is cool. So on Wednesday, we'll start to go into the database, and I think some of your projects, I'm hoping you guys are still thinking about what to do with your project. Once you understand once we get through the authentication part, using Firebase database is actually very easy. So on Wednesday, I will show you guys how to do that, and you might want to consider using that as a backend for your, for the app that you're going to write for this class, because it's just like, it's easier than SQLite that we talked about a few weeks ago. Alrighty, so I'll let you guys go, and if you have questions about what we talked about today, just go ahead and ask me. I'm gonna